All right, so here's a quick review of what you were supposed to get out of part four, sort of a overview. So first thing about part four is we talked about a bunch of probability notation. So I just want to quickly go through those different types of notation. We have what we call marginal probabilities, which is when we are talking about just a single outcome, so a single event. We have our joint probabilities. That's when we have our and, which we also sometimes see with the intersection notation. That's the mathier version of that. We have our compound, I think that's what they're called, our or probabilities, which we use sometimes the union notation for. And then we have our conditional probabilities, the givens. And finding these in terms of the wording in a question, pretty straightforward. For the and, we almost always see the word and. There are some other ways that we can see this besides the and between our two events. Typically, another way we might see this is the word but. But is another conjunction type word. It brings two ideas together. It just means that the thing that comes after is typically a complement, right? It's typically something we wouldn't expect. But we got the but. We've also see sometimes both, right, as a way to say and. So those are all ways that we can say and in terms of our probability notation. For or, again, we can use the word or. But we do have some subtler ways to talk about or. One of them you saw in the knowledge check last week, and that was if we only have two events, at least one is a subtle way to say or, because it could be one, it could be the other, it could be both. All of those things count in at least one. And then just to quickly show us graphically what each of these things represent on a Venn diagram, which gets us to the extra credit that was in last week's knowledge check. If we're talking about the and, this is going to be that intersection, right, where we had both of the things overlapping. That is always, always, always going to be smaller than just the thing by itself, than just one of the circles. It is the most constrictive in terms of what falls into it. We have our or. Now, or is anything in either of the circles. Like I said, that's our at least one. So for our or, that's actually always going to be bigger because it's going to be one plus whatever was in the other circle that wasn't included there. And then the last one, our conditional statement. This is, we always have to have this as a given, an of, or an if. These are the words you will see to let you know that we're dealing with a conditional statement. Whatever comes behind the given of or if, that's the piece we know. So it says if someone has long hair, that's the piece we know. That's what's going to go behind the line in this conditional probability statement. And there are multiple conditional statements on the test. It's one of my favorite things to test on. So definitely make sure that you can translate those appropriately. In fact, I'm going to give you an example from that tree diagram worksheet in just a second. Something else to note about this notation. One is the thing by itself, the marginal and the joint, these top two, these are on the table. If you've made a contingency table, they're on a table. There is no reason to do any calculation. Just take them off the table. In fact, if we had our table here next to this, all right, so this, if we look for an and, it's just going to be where those two things intersect on the table. If we're looking for a probability by itself, it's just going to be down in the total area. So we just pull those things straight off the table. There's no need to do any sort of calculation. In fact, this is the one thing that drives me crazy about what the Chegg tutor did for that particular worksheet, is they do a whole lot of unnecessary and complicated calculations for something that we literally can just see on the table. So that's why I particularly hate that Chegg work for that particular worksheet. Now the other two, there is no way to get these directly off the table. The or and the given, these you have to use a formula. There's no way around it. So for both the or and the given, you're going to use formulas. The or formula is given at the bottom of the worksheet. You add the two things together, and then you subtract the two totals, and then you subtract the intersection that you double counted. And then for the given, you're going to take the and probability and you're going to divide by the thing we know. So of all of the people who own a cat or whatever the heck our total is. And in fact, you guys have done conditional probabilities. That's what you guys did on that first exam with the cat and vegetarian vegan question. So These are the four different types of probabilities and how you calculate them. I will also show you that as a reminder, the four pieces of our Venn diagram, they are also the four pieces of my table. So just a reminder, if I have my Venn diagram with my A and my B, I have my overlap. I have the piece of A that's not in the B column. I have the piece of B that's not in the A column, and then I have the last chunk, which I'll just do in gray. This is everything that's not in the A or the B. So every one of those four pieces falls into that Venn diagram. Um, Typically speaking, you should use the formulas almost as a last resort. We should almost always be wanting to go towards one of these displays. And in order to use these displays, not the Venn diagram, but in order to use the table, you have to have an and you have to have the two probabilities by themselves. If you have and probabilities, that's a good sign that you're going to the table. The tree diagram worksheet, it's a tree diagram worksheet. So in order for you to use a tree, you need to have two conditionals for that to make sense. Ugh, that's ugly. And one thing by itself to split these up. And what should happen in order for us to be able to do this as a split, we should have whatever it is that we know, whatever thing we can split that on originally is going to be behind the line in one of these conditionals. So you kind of should know where we're headed in terms of these tree diagram problems before you even begin. Like you should know there's two conditional statements, and then we're moving from there. So let me grab the question stem on our tree diagram worksheet. Because if we were in class, this is where I would start for everybody. Is I would bring in this first part and we would translate the beginning, the very first sentence, together. So how I read through a tree diagram worksheet or question, which is going to be your warm and fuzzy on the next exam, is I sort of skip to the end and read and see if I've been given letters to use. And then I decide if I like those letters or not. So for this particular worksheet, I don't love the letters. It says A is equal to under 40, and B is equal to has an IRA. So I may decide I don't like A and B. Those are not like letters that bring me any joy that are related to these two events. So I might change these out and say, you know what, I'm going to use my own. I'm going to use U for under 40, and I'm going to use I for has an IRA. I could also use R for retirement. It doesn't really matter, but I'm going to choose letters that mean something more to me. So now that I know what the two events are that I'm looking for, I'm going to go read through the rest of the question, searching for statements about the age of the people, statements about whether or not they have an IRA. So let's read through. We can see here, I've done this work for us. The 28 is in a sentence, and I'm going to go ahead and this is the whole sentence. Boop, and then there's a period. So in that sentence, what are we told? Well, it says under 40, which we know is our U, having an IRA, which we know is our I. Now, we should not at all get distracted by writing an and here because we know we're moving towards a tree, and a tree has a given probability, right? It has to be conditional. So I should already know that since both are mentioned and it's a tree, it's got to be a given. But I also could come back in here and see, here's my keyword of given. Given, what comes right after it is you. So if they are younger, the chance of them actually having an IRA is 28%. And then if I know a little bit about my trees, I know somewhere later I have to know what the chance of being under 40 is. And so I'll go ahead and translate that last one for us. It does say currently the workforce is 56% of people who are under 46, under 40. So we got a percentage. The only thing here is under 40, nothing about having an IRA or not. This is our U by itself. So this is how you start a tree. You start with all employees, and then whatever thing we have by itself, we can split this into. So we have our under 40s, and we have our 40 plus. And so we know the probability of under 40 is 56. And then we can split this again into the IRA and no IRA using this probability of I given U. And then we can do this all multiplied together to find our ands. And I'm frozen. I'm going to kill Microsoft one day. You know that when I'm frozen, they can still see you when you do things like that, Chad. Tell me. Just, yeah. What? Yes, I'm trying to make a video. Oh, well, then you're in the video. I'm so sorry. Oh, okay. So I'm still recording. So anyways, this all then becomes, oops, the probability of I and U as we multiply down those rows. So some of you got way overthought this. You thought for some reason I would give you the ands. I would never give you the ands. If I give you the ands, you shouldn't be making a tree. So a lot of students went a very convoluted route, did a ton of extra work by trying to shove these three given probabilities into a table and then go backwards to the tree, or using one of them as an and trying to go backwards to the tree. No, I'm always, if I'm making you do a tree, I'm going to be giving you stuff that makes sense to build a tree with. So I'm going to be giving you these three splits that you would have in this tree. I'm not going to be giving you anything else. So if you're translating it otherwise, go look back at the sentence and see, is there really an and there, or did I just add an and for no reason? That's the most common mistake I've been seeing. So anyways, that's hopefully a little bit of help that'll get us started on the tree. If you are struggling with that, remember, you don't have to define, if you use the complement notation, what UC is. If you've already said U is under 40, UC is not under 40, so it's 40 plus. And these two things are always going to sum to 1. Right? The whole goal is every split of our tree sums to 1. And so the same thing here. If 28% of the people have an IRA, that means 72% of people do not have an IRA. But yeah, hopefully that gets us a little bit more squared away in terms of our trees, displays, and all those probability notations. Because I'm having such poor luck with my computer, I'm not going to do independent and disjoint stuff, but I'll throw that in another video and send that out later this week.